Let's see how to come up with a formula for compound interest. We'll start with an example. The example is this: 1000 rupees at the interest rate of 10% per annum. Per annum means per year, for 3 years. So for this example, let's calculate compound interest for 3 years. We calculate year by year. So for the first year, the principal is 1000, and at the rate of 10%, the interest is 100. So the amount is 1000 plus 100, which is 1100. This amount is the principal for the second year. That means the principal for the second year is 1100, and the interest on 1100 is 110, and therefore the amount is 1100 plus 110, which is 1210. This 1210 is the principal for the third year, and we continue the calculation. So let's label all these numbers. Let's call these principals as P1, P2, P3, and interest as I1, I2, I3, and the amounts as A1, A2, A3. Now we are going to calculate the interest, the compound interest, but we do the calculation year by year or period by period. And for every year, we are going to calculate the interest using the simple interest formula. What is the formula for simple interest? I equals PRT divided by 100. P is principal, R is rate of interest, and T is time or period. But here we calculate it only for 1 year at a time, year by year. That means T is always going to be 1. So if T is 1, the formula looks like this: I equals PR multiplied by 1 divided by 100. That means PR divided by 100. So if we use this formula, I1, that is the interest for the first year, is P1R divided by 100. You can see if it is right. If you substitute the values for P1 and R, you can get I1. That means if you say 1000 multiplied by 10 divided by 100, you actually get 100. So I1 is P1R divided by 100. What is A1? A1 is P1 plus I1, because you add 1000 and 100 to get 1100. So A1 equals P1 plus I1. Now in this formula, instead of I1, if I write the value of I1, which I calculated before, how will it look? It will look like this: A1 equals P1 plus P1R divided by 100. Just above this, we calculated the value of I1. That value we are putting here. That's why the equation looks like this. Now in this equation, you can see that there are two terms. The first one is just P1, and the second one is P1R divided by 100. There is no coefficient for the first P1. When there is no coefficient, the coefficient is 1. So it is really 1 P1. Now if you carefully look at this equation, you can see that P1 is in both the terms. And we know that AX plus AY equals A in the parenthesis X plus Y, or A multiplied by X plus Y. If you use this property here, you can write P1 multiplied by, in the parenthesis, 1 plus R over 100. That means the formula for A1 is P1 multiplied by 1 plus R over 100. Now let's keep this value of A1 aside and start working on the second year. For the first year, we calculated everything. We calculated I1 and then we calculated A1. Now let's move to the second year. We know that P2 is same as A1, right? You can see in the example above, A1 is 1100 and P2 is also 1100. So P2 is A1. But what does A1 equal to? You can look at the equation above. A1 actually equals P1 multiplied by 1 plus R over 100. That means P2 equals P1 multiplied by 1 plus R over 100. Now let's calculate I2. We have seen before I equals PR divided by 100. That means I2 equals P2R divided by 100. This is I2. Now let's calculate A2. A2 is P2 plus I2, right? Principal plus interest is amount. So A2 equals P2 plus I2. But what is I2? Just now we saw that I2 is P2R divided by 100. So let's substitute I2 with P2R over 100, and hence A2 looks like this. A2 equals P2 plus P2R over 100. Now again, the coefficient of first P2 is 1. So the equation looks like this. A2 equals 1 P2 plus P2R over 100. Again, you can see that P2 is there in the first term as well as in the second term. And we have seen before that AX plus AY equals A multiplied by X plus Y. Let's use the same property here. So we can write P2 in the parenthesis 1 plus R over 100. That means A2 equals P2 multiplied by 1 plus R over 100. But what is P2? If you look at the left hand side, the value of P2 is P1 multiplied by 1 plus R over 100. If you replace P2 with this value, the equation looks like this. A2 equals P1 multiplied by 1 plus R over 100 and multiplied by yet another 1 plus R over 100. When a number or a term appears twice in the product, what does it mean? It means that term or that number is squared. So now the formula looks like this. A2 equals P1 multiplied by 1 plus R over 100, the whole thing, parenthesis, squared. Now let's look at these equations for A1 and A2. What do you see here? You can see that there is a lot of similarity in these two equations. For A2, the power is 2. For A1, there is no power written. When the power is not written, it is always 1. So let me write 1 here. That means now the formula looks like this. A1 equals P1 multiplied by 1 plus R over 100 to the power of 1. And A2 equals P1 multiplied by 1 plus R over 100 to the power of 2. If you continue this calculation further, and if you calculate for the third year, you will see that the power will be 3. That means the formula is like this. A equals P multiplied by 1 plus R over 100 to the power of n. N here is number of years or number of periods. So this is how we come up with a formula for compound interest. It's a very useful formula. It is very important to remember this to solve any compound interest problems.